So thank you for the opportunity to present today. Like Chris mentioned, my name is Kun Nguyen from NIST. I have several roles at NIST. I'm the Smart Grid and Cyber Physical System Test Bed Manager at NIST. I also lead a project on testing and certification, and also serve on SEPA working group as the chair for the testing certification working group for SEPA. So today I'm going to talk about our work with SEPA, the Smart Electric Power Alliance, on a profile for electric vehicle managed charging that we are working on completing. So you heard from my colleague a little bit about the framework and the motivation for interoperability profile and such. So I'm going to do a little bit of deep dive. So here's the agenda item for my talk today. We'll talk a little bit about motivation. I'm going to be taking a different tack from what you heard from Avi. We're going through the looking at the landscape analysis and such in the field and why the needs is there for a profile around EV managed charging. We'll talk about our approach to do that. Talk about the use case, a little bit more detail on the use case than what you got from the last time, and then I'm going to talk about the next step and then any question that you may have. So for the landscape analysis, DER, the general term of distributed energy resources, can apply to a lot of things, right? So when you look at DER, the first standard to come to mind that you may be familiar with is IEEE 1547, 2018, the last updated in 2018. So 1547 applied to a lot of what we call inverter-based resources. Could be photovoltaic, fuel cell, dispersed generation, and energy storage. One thing that it does not apply to is electric vehicle. And the reason for that, there's several reasons, right? The 1547 is an interconnection standard. So you can view electric vehicle as an inverter that, does not, you can go plug it anywhere. So the interconnection is kind of strained for an electric vehicle. So that's why it wasn't quite covered under 1547, even though there are capabilities that could be applicable to it. Right? That's one of the things, because being that it's mobile, that's one of the limitations for the standard. The other good thing that 1547 has is that it requires local communication interfaces for the DER that enables some control from the electric utility or the system operator. And even though it doesn't quite cover communication specifically in standard, it recommends or it enforces at least one of these three protocol, communication protocol, so that that if you implement one of these protocol, then you conform to the standard. So the protocols are Sunspec Modbus, IEEE 1815, which is Distributed Network Protocol 3. And then IEEE 23.5, which is Smart Energy Profile 2.0. So, as long as you implement one of those protocols, you are compliant with 1547. So one of our partners in the working group, a utility, PPL Electric Utility in Pennsylvania, did a survey on EVSE, which is Electric Vehicle Serving Entity. They are looking at them based on communication capability for these devices. So what they have found is that they're using the three protocol from 1547 as the basis, and the motivation for doing that is for the utility, they have back office integration and stuff like that for DER. So they potentially could support one of these three protocol. So that's the lens that they have looked at the survey based on. So what they have found was that of the 25 plus vendor and equipment that they have surveyed, none of them actually support the three protocol natively, right? So that's the first takeaway. The second takeaway is that some of the company are working on developing gateway for supporting the EVSE for sub 2.0. Right, so that there is a stopgap measure to actually enable the communication through a gateway. So not natively, but you have to actually build a widget to actually attach to it and provide the communication capability. So the widget or the gateway provide the translation between the protocols so that you can actually get the message in and out and send control and stuff like that. And the good thing is that some of the companies are working on trying to implement SAP 2.0 communication for the EVSE. So you can look on the bottom here. There's quite a few things that they are supporting either natively or through a gateway. So OCCP, Open Chart Point Protocol, is pretty prevalent. OpenADR, which is Open Automated Demand Response, is also fairly prevalent. ISO IEC 151118 is a protocol for vehicle to grid capability. So there's some support there. And then 2030.5 is the one I mentioned. And then there's some just allowed API, which is Application Protocol Interface, Programming Interface. So they pretty much expose the data for you, and you can take it in and do whatever you need with it. And then 7 of them actually have proprietary communication protocol. So, as you can see, it's pretty fragmented. There's definitely a lot of things in play, and quite a few things that are not supported natively. So with that, what we got back from that landscape analysis is that industry want or need some kind of communication standardization for electric vehicles, similar to how it has been handled under 1547 for DER. So that's one of the needs that we found for the industry, and a motivation for our work. And then the other thing, being that I oversee, or at least I promote testing certification through my project, this is what we have found. I think Avi had covered some of that in his talk, that we did a lengthy analysis on testing and certification programs that are available for smart grid interoperability standard. So if you look at number 3, we start with the technology functional requirement on the bottom. That's the biggest chunk, right? And then the second chunk is the protocol communication that actually support devices to provide those functionality, right? So that's the second chunk. And then the top part is what is available for certification. So definitely there is quite a bit of a gap. And the way that we want to use the interoperability profile to solve this, or at least help build more program around for certification for product, is to then take a look at the protocol and the functionality and see where you actually can build something that can be certifiable as a profile.